Hello guys, trust you're doing fantastic. In today's video we're going to be talking about the excess 3 code subtraction of 9's complement. In this video we're going to be considering the case 2, which is to subtract a larger value from a smaller value. Now let's go over the rules. Rule number 1, take 9's complement and the excess 3 code for the subtract n. Rule number 2 says add it to the minuend excess 3 code. It means we need to take the excess 3 code for the minuend as well. Rule number 3 says if carry is generated, shift the carry to the next bit. Rule number 4 says add 3 to the carry generated bit and subtract 3 from the other bit without carry generated. Now it says if n carry is not generated, take 9's complement over again. Alright, so we're going to see how we can apply these rules to a question. Example: what is the 9's complement excess 3 code subtraction of 684.25 from 243.62? Now the equation by solution will be 243.62 minus 684.25, meaning that the first value on the left is the minuend and the value on the right is the subtract n, and which is the larger value. So the rule says we need to take the 9's complement of the subtract n. Thereafter we need to take the excess 3 code for the subtract n. So let's go. Taking the 9's complement for the subtract n means to subtract each and every digit from 9 in this value. So we're going to have 9 minus 6, 3, 9 minus 8, 1, 9 minus 4, 5, dot, 9 minus 2, 7, 9 minus 5, we're going to get 4. Alright, so the next step will be to take the excess 3 code for this result. Right, so we're going to take the excess 3 code for this result. Alright, so taking the excess 3 code for this result, it's going to be 315.74, the excess 3 code. So that would mean to add 3 to each and every digit in this number. So it's going to be 3 plus 3, 6, 1 plus 3, 4, 5 plus 3, 8, dot, 7 plus 3 is going to be 10, 4 plus 3 is going to be 7. So in this case, we have obtained the excess 3 code. So the next thing we need to do from this stage is to obtain the BCD for this value. Alright, so before we take the BCD for the subtract n, let's take the excess 3 code for the minuend. Right, so the excess 3 code of the minuend will be to add 3 to each and every digit in this number. So we're going to have 2 plus 3, 5, 4 plus 3, 7, 3 plus 3, 6, dot, 6 plus 3, 9, 2 plus 3 is going to give us 5. So in this case, we're going to take the BCD for the minuend and also the BCD for the subtract n. Right, so in this case, this is the subtract n and this is the minuend, the result we got for taking the excess 3 code. Now let's take the BCD for each of these values. Now the BCD for 648.107. Right, so this is nothing but the subtract n. So representing 6 in its equivalent 4 bits number is going to be 0110. 4 is going to be 0100. 8 is going to be 1000. Then we have the dot. This value here is 10. So 10 is going to be 1010, and then we have 7. 7 is going to be 0111. So this is the BCD representation of this excess 3 code value. Now let's go over to the next one. which is this. So taking the BCD is going to be the same procedure. You have 0, 1, 0 for 5, 7 is going to be 0, 1, 1, 1, 6 is going to be 0, 1, 1, 0, dot 9 is going to be 1, 0, 1, 1, 0, 0, 1, 5 is going to be 0, 1, 0, 1. Alright, so we need to carry out this addition, which is according to rule number 2. It says we need to add it to the minus n, so we're going to add these two BCDs together. Alright, so if we carry out this operation, we're going to have 1 plus 1, 0, carry 1, the carry is generated. Okay, it's taken over to next bit. 1 plus 1 plus 0 is going to be 0 with a carry generated. We have 1. So 1 plus 1 plus 1 is going to be 1 with a carry of 1 generated. We take it to the next bit. It's going to be 0 plus 1 plus 0 is going to be 1. So in this case, no carry is generated after this operation. Now let's move to the next segment of bits. 0 plus 1 is 1. 1 plus 0 is 1. 0 plus 0 is 0. 1 plus 1 is going to be 0 with a carry generated. Now this carry, we have to bring it down. So we have this carry generated. So we made this segment generate a carry. Now let's go over to the next segment. 0 plus 0, 0. 0 plus 1 is 1. 0 plus 1 is 1. 1 plus 0 is 1. In this case, there is no carry generated in this segment. Now let's go over to the next segment. 0 plus 1, 1. 0 plus 1, 1. 1 plus 1 is 0 with a carry. Okay, we'll take it to the next bit. 0 plus 1 plus 0 is going to be 1. So in this case, there is no carry generated in this segment of bits. Now let's go over to the next segment of bits. 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 1 is 0 with a carry of 1. Now 0 plus 1 plus 0 is 1. So in this case, there is no carry generated in this segment. So we notice only one of the segment generated carry. Now the rule says, according to rule number 4. So let's see what the rule says. Alright, so the rule says if carry is generated, we need to shift it to the next bit. So carry is generated in this segment of the bit. So having obtained this result, so carry is generated in this segment of the bit. So the next thing we need to do is to shift this carry to the next segment of the bit. So we need to perform this operation. We need to add it up. So in this case, we're going to have, since nothing is yet to add, so the same value, we're going to bring it down. Okay, we're going to have 0, 0, 1, 1. So this part, since we have shifted the carry to this other bit segment, so it means this value, we're going to bring it down 1, 1, 0, 0. Alright, so this part, we need to perform this operation because we have this carry that has been shifted to this segment. So it's going to be 0 plus 1. We're going to have 1. We'll bring down this one, bring down this one, bring down this one. So this part has nothing to add with. So we're going to bring down exactly what we have here. We're going to have 1, 1, 0, 1. Then we're going to have 1, 1, 0, 1. Alright, so in this case that we have seen that only one segment generated carry. Other segment did not generate any carry. According to the rules, it says we need to add 3 to the carry generated bit and subtract 3 from other bits without carry generated. Alright, so in this case, that is why we have this. So we're going to have minus 3, okay? This part segment did not generate any carry, so we're going to have minus 3. So 0, 0, 1, 1 represents 3. Now this other segment did not generate carry. We're going to have minus 3. Alright? So this other segment did not generate carry. We'll have minus 3. Then this is the part, the segment that generated carry. So in that case, we're going to say plus 3, 0, 0, 1, 1. This other segment did not generate carry. We're going to say minus 0, 0, 1, 1, which is 3. So let's carry out this operation and let's see what we're going to get. 0 plus 1 is 1. Right? Is 1. And then we have, in this case, it's minus. Rather, it's not plus. So 0 minus 1 is going to give us 1 with a carry. Now this is the carry generated. Now I say 0 minus 1 minus 1. This is going to give us 0. Right? It's more like saying 1 minus 1. You're going to get 0. Now you say 1 minus 0. You're going to get 0. 1. Now let's look at this operation carefully. Now this is minus. This is addition. This is minus, minus, minus. Now if we have to carry out subtraction, so let's go over the rows. So we have 0 minus 1. That is going to give us 1 with a borrow. So in this case, we're going to borrow from the next bit. So we're going to look at this bit. This bit has 0. So we'll look at the next bit. The next bit is 1. So we have to borrow 1 to this next bit. All right. So this one is indicated with this gray ink. So you have 1 that's been borrowed to the next bit. So this is going to give us 0 minus 1 is going to give us 1. We borrow 1 from the next bit to this other bit because this bit has 0. So checking on this bit, it's 0. So we have to move to the next bit and then borrow 1 and then give it to this bit. So in this case, we have 1. So 1 minus 1 is going to be 0. Now this bit, we've already borrowed 1 from this bit, so this bit will become 0. So we say 0 minus 0 is going to give us 0. And then finally we have 1 minus 0 is going to give us 1. So this is how we arrive at this value. Now let's go over to the next segment. 1 plus 1 is going to be 0 with a carry of 1. 1 plus 1 plus 1 is going to be 1 with a carry of 1. 0 plus 1 plus 0 is going to be 1. And then 0 plus 0 is going to be 0. Alright, so let's take the same principles of subtraction. So we say 1 minus 1 is going to give us 0. 1 minus 1 is going to give us 0. 1 minus 0 is going to give us 1. 1 minus 0 is going to give us 1. In the next segment, we have 1 minus 1, 0. 1 minus 1, 0. 0 minus 0, 0. 1 minus 0 is going to give us 0. Let's move over to the next segment. 1 minus 1, 0. 1 minus 1, 0. 0 minus 0, 0. 1 minus 0, 1. So in this case, we have obtained our result. So the next thing we need to do, since the rule says that we need to add 3 to the carry generated bit and then subtract 3 from the bit without carry. Now we have done this. So after obtaining this result, the next thing we need to check if n carry is generated. Now if n carry is not generated, in this case we did not generate any n carry. It means after the last operation from the last segment, we did not generate any n carry. Okay, so in this case what we need to do is we need to take the 9's complement again, because in this case it means the result is negative. So therefore we need to take the 9's complement of the result. Now taking the 9's complement of this result simply means we are taking the complement of it, similar to what we call the 1's complement. So it means we're taking the inverse of it. So in that case, taking the 9's complement of this value, it means we just need to take the complement of it, the inverse of it. Means where we have 1, it will become 0. Where we have 0, it will become 1, 0, 1, 0, 1. So taking the complement of this is going to be where we have 1 is going to become 0. Where we have zeros, everything becomes 1's. In this part where we have 1's, everything becomes 0. Where we have zeros, everything becomes 1's. Dot. Where we have 0 becomes 1. When we have 1's becomes zeros. When we have 0 becomes 1. The same thing applies where we have 1 becomes 0. When we have zeros become 1's. And when we have 1 becomes 0. So this is nothing but the 9's complement. Okay. So in that case, since we have done this, we need to get the equivalent of this bit, binary bit in decimal. So 0111 is going to give us 7. Now don't forget, because n around carry or n carry is not generated, therefore the result is negative. That's why we got this negative, right? So this is 7, this is 7, 0011 is 3 dot 1001 is 9, 0110 is 6. All right, so if we have to subtract 3 from each and every digit in this number, we're going to get 4. That's 7 minus 3 is going to give us 4, 7 minus 3 is going to give us 4, 3 minus 3 is going to give us 0 dot, 9 minus 3 is going to give us 6, and 6 minus 3 is going to give us 3. All right. Hence, minus 773.96 is nothing but the excess 3 code of minus 440.63. So if you've gotten to this part of this video, it means you have gained sufficient knowledge in excess 3 code subtraction. I'm going to encourage you to pay attention to the subsequent videos in this channel. Alright then.